Welcome back, students. In our lesson today, we're going to be talking about initial value. So a word to keep in mind here, initial means, oh, it won't underline, there we go. Initial means start. So let's think of other places where we hear the word initial. Give your initials, right? Your initials are the starting letters of your name, an initial start time. So when things are going to start, or an initial speed. That's the speed something was going when they started timing it. So initial, again, means that start. An initial weight is that weight at the beginning of something. So initial start. So our key concept, a linear function can be written of the form y equals mx plus b. This isn't the first time we've talked about a linear equation, and function is just a fancy word for equation, but a special equation in which each x value has only one y value. So things to keep in mind, m is our slope or rate of change, which we were talking about last section. Make that look like an O. And b is our y-intercept, or now known as our initial value. And if you remember when we went to graph these, we would say begin at B. So beginning meaning initial. In a graph, we're going to find that initial value of a function at the y-intercept, right? So this is where our initial value is. Here it's talking about our rise over our run, which is our slope, our rate of change. And then it tells you that the initial value equals the output when the input is 0. So when the input is x. Remember, output's y, input is x. So when x is 0, that's our initial value, which is our y-intercept. From a table, that was the last thing. From a table, your initial value is the y value when x equals 0. So again, we talked about how we knew our y-intercept if we're looking at a table because x equals 0. It's the same thing for our initial value. When we're looking at a table where x equals 0, the y value is our initial value. All right, so example 1, match each function below with its initial value. So I'm going to just start with a. My initial value is the y-intercept. So here, my b value, that's what we're going to call it, is going to be a -2. And when I look at b, my initial value is 3. And I know this one's in a different form, looks different, but if we remember the commutative property, y equals 3 minus 3x is the same as y equals -3x plus 3. So keeping in mind that our signs move with our numbers. So b has an initial value of 3. C has an initial value of 3. So our initial value here is 3. Our D initial value is 2. So if we're just looking at an equation, it's that b. What does b equal? So when we're looking at that equation, we want to remember y equals mx plus b, and that we are looking for that b. And that is our initial value. All right, so example 2. Josie has 1.5 cups of water in her watering can. She fills the can before watering her plants. The water flows into the watering can at a rate of 1 cup every 4 seconds. The graph represents the function described in words. So what is described up here in words is represented here as a graph. And now we want to write each value of the equation for the linear function. So we want to find the rate of change of the function. So that's our slope. These first two are the same thing. And so I could sit here and find, I wouldn't use the points they give. I would, if I'm going to use points, I'm going to find my own that fall on the graph itself, right? So here at 2, 2, and here at 10, 4. And then in order to find this rate of change or slope with a line, I'm going to do, so both of these have the same work. I'm going to do 4 minus 2 over 10 minus 2, which gives me 2 over 8, which is equal to 1 over 4. Now, I got that from the graph, right? And I can even, because this is counting by 2's and that's counting by 2's, I went up 1 and over 4, so that's okay. The other thing is it tells us right up here, rate of 1 cup every 4 seconds, right? 1 cup every 4 seconds. So our rate of change equals 1/4, m equals 1/4, because they are the same. Okay, y-intercept of the line and the initial value of the function. Guess what? Well, those are the same thing. Where do we start? Well, this gives us our point, but I'm going to come back up here where it tells us that she has 1.5 cups of water in her watering can. And so B is going to equal 1.5 cups. Now it wants the rule. Well, we write function rules of the form y equals mx plus b. So I know my m is 1/4. Y will equal 1/4 x plus, and then my b is 1.5, so 1.5. The other way, we could write this, or y equals 1/4 is equal to 0.25. So 0.25 x plus 1.5. Now, how do you know when to do which? It'll either tell you or it's going to give you a multiple choice option. But both of these are correct. All right. Example 3. The linear function in the graph models the height off the ground in feet of a person riding a zip line t seconds after pushing off the platform. We just want to know how high off the ground is the platform. So I can look at this in 2 ways. I can look at, if it gives me an equation, I can go to the equation and figure it out, or I can look at the graph. Right, so if I look at the graph where x is 0, y is 100, and so we are 100 feet off the ground. But I can also look at my equation and I can see it right there. But that's how simple that initial, how high off the ground is the platform? Oh, it's 100 feet off the ground. That's where we start before we go down the zip line. So I hope that was a nice refresher, basically all over y-intercept, just using it in real world examples. And until next time,